Assalamualaikum and hello everyone. Today, my team and I are going to share something really interesting. It's called Bernoulli's principle, and it's one of the reasons airplanes can fly. We will explain how it works, how it helps airplanes take off and stay in the air, and even where we can see it in everyday life. I am Nurfat Adel, and these are my teammates. Azrina Nadia, Nur Ali Shamimi, Qasriena Nur Zahra, and I Nubatishar. We hope you enjoy our presentation.
Who was Daniel Bernoulli? Swiss physicist and mathematician, 1700 to 1782. Studied fluids dynamics, discovered relationship between pressure and fluid speed. Daniel Bernoulli laid the foundation for what we now call Bernoulli's principle, crucial for understanding flight. Lifting force, push the plane up. Drag, against forward movement. Weight, pull the plane down. Thrust, push the plane forward. Why are airplanes' wings shaped by a force?
Airplane wings are specially designed in the shape of an airfoil, curved on the top, flat on the bottom. When the airplane moves forward by the engine, air above the wing moves faster, air pressure decreases. Air below the wing moves slower, air pressure increases. This difference in pressure pushes the wing upward. Lift occurs.
For instance, first, the engine generates weight. Second, the wings produce lift when air flows over them. Third, when the lift force exceeds the weight of the airplane takes off. And the last one, for the control, is achieved using the tail and small wings.
Thrust and drag. Thrust is a force that pushes the airplane forward. It is produced by the engine, that engines are propellers. The faster and the planes move forward, the more air flows over the wings, helping to create lift. Drag is the resistance force that acts opposite to the plane's motion. It is caused by the air pushing against the aircraft. Designed to reduce drag by making planes smooth and streamlined. Think of the thrust as the push forward and drag as the air trying to slow it down.
Types of aircraft engines. Jet engines work by sucking in air, compressing it, mixing it with fuel, and igniting it. This explosion creates high-speed exhaust that shoots out the back, pushing the plane forward. That is Newton's third law. For every action, there's an equal and opposite reaction. Propeller engines. It uses spinning plates to pull or push air backward, which moves the plane forward. We mostly see these on smaller planes or older aircraft. Turbofan engines. It is a type of jet engine and are the most common in commercial airplanes. They combine jet thrust with large fan that move a lot more air, making them more efficient and quieter. Here's a simple graph showing how lift increases with speed and airflow. This connects to Bernoulli's principle. As air moves faster over the wing, pressure drops, creating lift. It controls the bases. Planes move in three ways: roll, pitch, and yaw. These are controlled by parts of the wing and tail. Ailerons on the wing, they control roll. Elevators on the horizontal tail, they control pitch. Rudder on the vertical tail, it controls yaw.
Stability and balance. Stability in an airplane means its ability to maintain or retain steady, level flight without constant input from the pilot. It's a crucial factor for safe and smooth flying. Center of gravity versus center of lift. Center of gravity. This is the point where the airplane's balancing point. Center of lift. This is rate lift. The upward force generated by the wings is forecast.
Flaps and slats. First, located on the wings. These parts are extended during take-off and landing. Second, they increase lift at slower speeds, allowing the plane to safely lift off and land without stalling. And the last one, flaps are on the back edge of the wing, and slats are on the front edge.
Material used in aircraft. Airplanes must be light, strong, and resistant to corrosion. Engineers choose material carefully. Aluminium, widely used because it's light and doesn't rust. Titanium, strong and heat resistant, used in engine part. Carbon fiber composite, lighter than metal and very strong, used in modern planes like to Boeing 787 and Airbus A350. This material have improved fuel efficiency and safety. Navigation system. To these planes use advanced system to navigate the skies. Autopilot maintain altitude, heading, and speed, helping reduce pilot workload. GPS tells the plane its exact location. And flight instruments such as the altimeter or altitude, airspeed indicator, and artificial horizon help pilots fly safely, even in poor visibility. Environmental impact. Airplanes are very fast and efficient, but they also affect the environment. Jet fuel emission release carbon dioxide or CO2, contributing to climate change. Noise pollution affects communities near airports. The solutions are being developed. Sustainable aviation fuels or SAF made from plants or waste, reducing CO2 emission. Electric aircraft. Electric aircraft is still in testing but could lead to cleaner short flights in the future. Cabin pressure and altitude. Most commercial airplanes fly at around 35,000 feet, about 10,000 meters, where the air is too thin to breathe. That's why the cabin is pressurized. Air is taken from the engines, cooled and compressed, and pumped into the cabin to maintain a safe and comfortable pressure, roughly equal to what you felt at 8,000 feet. This prevents passengers from getting sick or dizzy due to lack of oxygen.
Bernoulli's principle isn't just used in airplanes. It's actually part of our everyday lives too. Let me show you 3 cool examples. First, let's talk about soccer. Soccer ball curve magnet effect. When a player hits the ball with a spin, the air moves faster on one side and slower on the other. This creates different air pressures, lower on the fast side and higher on the slow side. That pressure difference makes the ball curve through the air. This is called the magnet effect, and it's powered by Bernoulli's principle. Next, spray bottles and atomizers. When you press the nozzle, it pushes up and really fast. That fast-moving air creates low pressure, which pulls the liquid up the straw and turns it into a mist. So every time you spray perfume or cleaning fluid, you are actually using Bernoulli's principle too. Lastly, Formula 1 car aerodynamics. They are shaped with wings, but upside down. This design makes air flow faster over the top of the car and slower underneath. It creates low pressure above and high pressure below, which pushes the car down on the track. This is called downforce, and it helps the car stay stable at high speeds. All thanks to Bernoulli's principle. So, from the soccer field to your home and even to high-speed racing, Bernoulli's principle is all around us.
Conclusion. Bernoulli's principle explains how the distributed wing shapes is a center combines with chairs and cultural surface for flights. Science makes flight possible. Thanks to Bernoulli, we understand how something as heavy as an airplane can soar gracefully in the sky.